Okay, we're live. Great. Welcome everyone. Welcome for this new session of the PlumD Labs Lightning. Like usual, we'll wait for a few more minutes so that everybody can join us. As usual, I forgot to turn out. Perfect. Yeah, feel free to drop a little comment in the YouTube chat or in the Telegram live chat to say hello, to tell me if everything is working fine, if I need to improve the sound or anything like that. And we'll start in a minute. Let me just post a message saying that we are live. And we're going to start in a minute. I'll just share again on Twitter as well. There you go. Perfect. So while we're waiting for more people to join, let me share again the slide where we present quickly the lab's initiative. Basically, the idea is to keep track of recent things happening in the Lightning Network, recent developments, new wallets, new parts of the specification, new tools, all this kind of stuff, to sometimes and sometimes linked to the news, try to dig deeper into some specific aspects of how the Lightning Network protocol works. And a long-term goal is also to be able to have a community of students that can contribute back to the Lightning Network ecosystem by, and notably by developing tools, by conducting research and things like that. As the name Labs implies, it's more of a technical community, even though, of course, everyone is welcome here. And so we are meeting twice a month, sorry, so every 2 weeks. And we have also, so we are doing these live sessions every 2 weeks on Tuesdays at 4 p.m. CET, Central European Time. And yeah, we have this Telegram group, which you can join. You'll just have to fill a little captcha because we don't want bots there. And in this group, we can share news articles related to Lightning Network, research papers, things like that. That's where we announce all this kind of stuff. Great. I see that we are 3 now. Once again, feel free to drop a little message in the chat saying hello. And yeah, we'll start with a little yeah, what we're going to see today. We have a few, so it was not, the last 2 weeks were not very, there wasn't just a lot of groundbreaking news, but there was, yeah, the kind of stuff that you expect when people build slowly but surely. So we've got a few implementation releases. From 3 of the 4 major implementations, we've got some LND release, some core Lightning, and some LDK release. We've got Antoine Rillard, who shared a feed bumping vulnerability. So he cross-posted this to the Bitcoin Dev mailing list as well. We've got René Picard, who, for those who don't know him, is a researcher on the topics around managing liquidity on the Lightning Network, ensuring that you can reliably send payments across the network thanks to optimal path finding, and also how to rebalance liquidity on the network so that payments can reach the destination, all this kind of stuff. And he recently released, so I think it was a few days ago, like maybe a week ago, I think it was 6 days ago, something like that. He shared a notebook, a Python notebook with some research findings. And then we'll take some time to talk about other tools and projects. For example, there is Boltz Pro, which was released. So Boltz is non-custodial Bitcoin bridge. Basically, they allow you to swap funds between Lightning, on-chain, Liquid as well now. Yeah, and so we'll cover their latest announcements with Boltz Pro, and we'll also take a look at some other things, like, for example, a little tool that I found interesting, which is a little project around LN and this kind of stuff. Hello, Yolu, welcome. Thanks for saying hi in the chat. Yeah, so that's it for a little plan of what we're going to see today. So maybe now let's start. I think we have 6 people. Let's start with the implementations releases. So we've got, as I said, in the last 2 weeks, we've got releases from LND, LDK, and Core Lightning. So none of these releases were a big, huge release with a lot of lots of changes, but still there are some things worth pointing out. So let's start with LND. So 2 weeks ago, we covered the release of the version 0.19.0, which notably enabled the RBF simple close protocol. So basically the ability to, basically it was a new protocol for closing a channel in a collaborative manner, which enhanced the previous protocol, made it a bit simpler, enabled the ability to RBF this kind of transactions, things like that. And so I think it's now cross-compatible between at least Eclair and LND. Yeah, and so one of the fixes, so basically the 19.1 beta release was basically a lot of bug fixes. One of them was, so I mentioned the RBF simple close protocol because one of the fixes was a case where when both peers were running a version 0.19.0 and were supporting this new RBF simple close protocol, there were cases where when you try to disconnect from this peer, so for example, when you try to shut down your node will try to cleanly disconnect from peers, and there was some bugs here that led to the connection being in a weird state, and so they fixed that. They also fixed a memory leak, so this kind of stuff, which is always good. And as a side note, because we didn't cover it, because I missed it in the last session, but it's quite important, in the latest major release in 19.0, Lightning Labs also introduced a migration path. So from the existing database model, which is a key value database, to a real native SQL database like Postgres database. And so for now, it's only for the invoices database, I believe. I think they're working on migrating the payments database as well. And so it's quite important because LND nodes are known, especially for big nodes with a lot of activity. They are known for suffering from a huge inflation of the database size. And because it's kind of key value databases are not really well suited for handling such large amounts of data. And so you have to, for example, often do database compaction and things like that. It can take some time. And so now they are, right now, if you start a new node, from the get-go, you have the ability, the option to start from scratch with a real Postgres or whatever SQL database. And now they are adding migration paths for people who already run nodes and want to switch from the key value database to a native SQL database. So it's a bit technical, but it's great for node runners, and especially node runners who have large nodes with a lot of payments and invoices. We also got a new release from Core Lightning, which was actually only this morning or maybe during the night, depending on where you live. It's made peer storage a default. Before that, it was an experimental feature. And so for those who don't know, we covered this, I think, in like a few months ago. But peer storage basically is the idea that you can store a copy of some of your channel data, an encrypted copy, in with your peer. So your peer is storing this, and if you need to get a backup, you can ask your peer if you want. So yeah, it's great for recovery, for example. And so now it's a default feature and not an experimental feature anymore. And now two things worth noting. They made a breaking change to their experimental splicing implementation. So they have a splicing implementation. And in order to make it interoperable with Eclair, because I think Eclair has the longest standing splicing implementation, they had to introduce some breaking change with their own implementation of splicing, which means that if you upgrade your core Lightning node to the version 25.5, you will be interoperable with Eclair nodes, but you won't be interoperable with previous version of core Lightning, for example, 25.4. So that's something to keep in mind. If you do upgrade, you might have some trouble with existing peers. That's why they explain this in the release notes. You will not be able to reestablish channels with older nodes at all if this is enabled. So you have to be careful with that. And so if you have core Lightning peers with the experimental splicing feature, consider disabling this option until they upgrade to support the latest draft spec. So when you restart your node, maybe disable the experimental splicing option if you have peers that didn't upgrade yet. So yeah, it's a bit chicken and egg problem. We have to wait for all your peers to upgrade if you want to do this experimental splicing with them. But yeah, just a little warning around that. And they also did early support for LSP's client. So inside the core Lightning node, the ability to buy channels, buy inbound liquidity from an LSP right inside the core Lightning node, which is great. So for now, it's really early support. It's only implementing the first document of the LSP specification, so LSP0, which is basically the base transport protocol. But it's the first step into adding support for a standardized way to interact with LSPs right from the core Lightning node, which is, I think, great, instead of having to rely on some external tool. We also got a release for the core Lightning graphic user interface, which is great. And now I think it really looks great. And so you can see it look like that. I don't need the sound, thank you. And you have now a lot more bookkeeping details, which was a bit lacking previously, with account events. So like when you receive, send funds and stuff like that. And yeah, all this kind of stuff looking very good. Some graph regarding the flows of funds, so that you can really visualize what's going on around liquidity, all this kind of stuff. So very, very great to see this. Yeah, close that. And and there is also, I forgot to show that because it's interesting. There is also now really a way to directly from this graphical interface send SQL queries to your nodes. So for example, here you select all the peers from the nodes database, yeah, which can be useful sometimes when you only have access, for example, to this interface, this graphical interface, and not to a terminal session, for example. It can be useful to be able to issue queries directly to your node using this tool. And we also have a LDK node release, which was mostly bug fixes. And at the same time, we have V3 channels that start to be implemented in the in the Rust Lightning repository. So channel establishment for V3 channels. So V3 channels are channels that use V3 transactions. So basically being able to have encore zero fee. So we covered this a bit in, I think in 2 separate sessions, the ability to have encores that have a zero value. So now that it is included in Bitcoin Core 29, Lightning devs can start to work to use this as part of the Lightning protocol. And if you're wondering, we covered this in a few previous sessions. Great. So I think that's it for implementations releases. Feel free to ask if there are any questions, of course, either in the YouTube chat or in the, we have a live chat channel in the Telegram group where you can ask all the questions you want. And you can also join me on stage if you want to discuss something together by voice. It's also something really possible, and yeah, it would be a pleasure to have you on stage with me. So just send me a message if you want, and I can have you join. Perfect. Now to the fee bumping vulnerability disclosure from Antoine Ria. So Antoine Ria shared this vulnerability through, so he made a blog post, so not really a blog post, but he published the report on his website. And he also cross-posted this to the Bitcoin Dev mailing list. And so this is a vulnerability affecting Anchor outputs. And I think, yeah, it's already known around all the implementations. I think it's already quite identified across the whole Lightning community. But still, it's great to have an official disclosure. So some things to bear in mind in Antoine's report. He said that the attack has been affected with this CVE number. I couldn't find it on the CVE database, so maybe it hasn't yet gone through the whole process. I don't know where it's being tracked, this number, but the MITRE, which is the American and the US entity responsible for tracking CVE numbers, so vulnerability numbers, doesn't have such a number in its catalog, or at least I couldn't find it. So yeah, just wanted to mention that. And so the core idea of this vulnerability is that if, so when you are using Anchor channels, the idea, and I think we covered it in a few sessions already, the idea is that when you exchange commitment, when you create commitment transactions in Lightning, which commit to the state of the channel at any given time, you don't know when you are going to publish the transaction. And so especially you don't know what the fees are going to be at the moment when you need to close the channel, to force close the channel, which means spending this commitment transaction. And so one of the way around that is to have what we call Anchor outputs, which are basically 2 additional outputs, 2 dust outputs. And now there can even be 0 amount since Bitcoin Core 29. And the idea is that you don't have to commit that much to the fees inside the commitment transaction itself, because you can always bump the fees of the commitment transaction, when you publish it, when you broadcast it, when you want to close the channel, simply by using chat pay for parent, so CPFP, and so by creating a second transaction that spends from the commitment transaction using the Anchor. So we covered in a previous session, we covered quite extensively why there are 2 Anchors and all this kind of stuff. But basically that's the idea. And if you're a bit astute, you'll see that in order to bump the fees of the transaction, you need to spend from the Anchor, from the original commitment transactions. And that means that you need to have funds available on chain in order to create this second transaction that is going to pay for the fees of itself and the parent transaction, which is the commitment transaction. Um, and so, and additionally, in order to be able to do this in a timely manner, you may want to have these funds available in the hot Lightning wallet, so available to the Lightning node itself, so that it can automatically bump the fees, for example, if required. You don't want to rely on, for example, the node operator saying that they need to bump the fees of the transaction and then reaching out for funds in a separate wallet. That's not really practical, and it could lead to loss of funds if they are not reacting quick enough. So that's why you want to delegate this and automate this task with the Lightning node itself. So you want to have the funds presumably inside the Lightning node's on-chain wallet. And so now the idea behind the vulnerability is that if an adversary, an attacker, can guess that what funds you have available to spend the encores, so if they can guess that you don't have enough funds to spend the encores, depending on what the fee rate is currently on chain, then they could try to artificially increase the weight, so the size of the commitment transaction, in order to make you unavailable to bump the fees of the commitment transaction enough to have the commitment transaction confirmed in a timely manner. And so they could use this, for example, to steal funds if really you're unable to bump the fees of the transaction enough. And so this increased weight can be achieved by several ways. Basically, the idea is that you need to make me spend more funds on fees to the point that I can't really bump the fees of the transaction enough so that the commitment transaction will confirm quickly. And you can do that either by opening new channels. And so it means that I have to, and see, if you force close all the channels, I have to pay fees for each of these channels. You can also do the opposite. For example, if I'm an LSP, the attacker could request channels from me. And so for each channel, if it's then force closed, I need to also be able to fee bump the transaction. And so that's something to bear in mind for LSPs, for example. And the most cost-effective attack vector would be the last one, which is routing payments, routing HTLCs through my node, but not settling them. A bit like in the jamming attacks, where you send payments through a routing node, but you don't really intend to settle them. And so for each HTLC in the channel, it's one additional output that is created in the commitment transaction. And it can lead to the commitment transaction being EV, especially if there is no restriction on the number of HTLCs. So the absolute cap in the number of HTLCs is 483 HTLCs per channel. It comes from the max number of the max size of a transaction, and so you can create the commitment transaction with more than 483 HTLCs because it would be too big. But usually there are lower limits that each implementation can set, and can also be a value that the node operator can decide on. But basically, you could quite easily increase the size of a channel by routing HTLCs through it and then force closing the channel. And so if the victim, if the target node doesn't have enough funds available to bump the fees of the commitment transaction to make it confirm, then the attacker could even steal the funds of the channel. And so what do we do to avoid that? Some mitigations. One that Antoine Riard proposes is to compute a dynamic required fee bumping reserve. So to adapt what funds should be available for the Lightning node to spend on chain at all time, with some simple formula, which is the number of open channels, what he calls the max channel weight surface, so what you accept as the maximum weight for a channel, and the worst case fee rate per kilowatt, per kilo weight, sorry. divided by 1000 because here we have kilowatt. And so if the nodes, the available funds fall under this reserve, then we show a warning to the user, or we can even restrict channel opens. So for example, the node could decide to block new channels opening, even block routing, so refuse HTLCs. So yeah, you could do one or both of these things. And some of the work, I think, on channel jamming mitigations might be useful as well to prevent, because it's I think it's quite similar classes of attack, especially if, I mean, it uses one of the same attack vectors by routing HTLC through target node to exhaust some resources. So maybe the mitigations put in place against jamming could be useful to prevent abuse in this vulnerability as well. And regarding the third aspect, the first mitigation, some wallets, I know at least LBUp does this because I saw it on mine. Already display a warning when the on-chain balance that is on the Lightning node is small, but I'm not sure it's a dynamic value yet. I think it's more of a fixed value. But still, it warns you when you don't have a lot of funds available on chain to bump the fees of potential force clauses. So yes, that's it for the vulnerability. You can find the reports following this QR, as always. And yeah, if you have any questions, feel free to drop them in the chat. Great. Let me check if there are no questions anywhere. It's good. Great. And now to channel rebalancing research. So it's a post published by René Picard. Let me show you the link on Delvin Bitcoin. So 6 days ago, as I mentioned in the beginning. So where René shared their latest research notebook, which you can find here on their GitHub. And so a notebook basically is a file with text that explains everything, and then the code that you can run on your end to see to conduct, to reproduce the research yourself, if you will. So yeah, it's called Python Notebook, and you can download it and take a closer look at it if you want. It's a lot of math, and we are not going to be delving into this too much because I don't necessarily understood everything, and it's not necessarily it would take a lot of time to explore it really deep enough for it to be interesting, I think. But so basically, what René was looking at is what can we do once in the network, in a given Lightning network, all the or most of the channels are depleted, which means the liquidity is mostly stuck on one side of the channel, like 10% of the liquidity is on one side, and then the 98% remaining are on the other side, and it doesn't really move anymore. Then what can we do? The question basically is what can we do in terms of circular rebalancing, so moving liquidity on the Lightning network in cycles, in cycles, so that when a node moves liquidity, what he sends on the channel, he regains on another channel, so that no node loses money. And so what can we do in terms of circular rebalancing, so without involving any on-chain swaps or things like that, in order to overcome this channel depletion? And so basically, we start from a state where channels are depleted. We have a set of solution states where we'd like to end, where channels are mostly not depleted, so are mostly 50-50 in terms of liquidity. If your assumption is that target liquidity is 50-50, but you could change that, for example, if you want. And then it's you have to try to solve this this equation basically. And so it uses I think, two approximations to you mentioned that. Where is it? Yeah, two-phase approximations, first continuous relaxation and then integral approximation. So yeah, basically the core thing to understand is I think the most interesting thing at least is the result. So it started with a state where the network is evenly depleted. So in that case, it's like 10% of channels only have balanced liquidity, which means in this case, each peer has between 40 and 60% of the channel capacity. And then it basically the algorithm tries to find a solution to the problem. Basically, what cycles, what circular rebalancing should be done in order to end up in a better state. And it managed to find a solution leading to the number of balanced channel reaching more than half of the channel, so from 10% to almost 60%. And also channels that are moderately imbalanced, so both peer on between 10 and 90% of the channel liquidity. So it's not balanced, but it's not as imbalanced as almost everything on one side and nothing on the other. And so this proportion rises to 95% from 41%. So we more than double that. And we achieve that by moving a third of the total network capacity. And so that's what we can see here in this graph. In blue, it's before rebalancing. So if you try to, so CDF is basically the cumulative distribution. So this means here, if we take a look, the blue curve starts at, let's say, 0.25. It means that 25% of the network is completely imbalanced. 25% of nodes have zero liquidity on their sides, which means conversely that 25% of the network have all the liquidity on their side. And then it's basically it's a straight line kind of between them, but you can see that there are a lot of nodes that are imbalanced. And after the rebalancing, we see that there are a lot less nodes on the extremes, like 1 or 2%. And then we have a steep curve in the middle, which means that there are a lot of nodes that are in the middle where they are quite balanced. So for example, here between 0.4 and 0.6, it means that one node has between 40 and 50% of the channel capacity on their side, and the other node has between 50 and 60% of the channel on their side. So quite balanced. So yeah, but there are also some caveats to have in mind. And so this is really to be seen as quite theoretical work. It was more to see what is possible to do. Why? First, because it requires network-wide coordination. To do this, to achieve this kind of result, you need to be able to have all the nodes coordinate together to move the liquidity where it's better that it is according to the result of the computation. And second, the computation itself is quite intensive, so it takes a lot of computational power to find the solution, and then before being able to then do what the computation suggests to do. And as René Picard points out in the article itself, I don't know where exactly. Let me look. Yeah. He has a question: is it even worthwhile to continue to think in this direction? It is my understanding that many node operators assume liquidity management via fees is the way to go. Because here in his simulation of the network, of course, node operators don't try to modify the liquidity distribution by switching incentives through fees. And so indeed, it seems it's given all the practical limitation of this approach, um, it seems to be a generally agreed thing that you can more efficiently and at least more practically adjust liquidity through fees. So, for example, if you receive a lot on one side and you want to rebalance your channel, you're just going to put a high fee on the side on which you receive, and to reduce the fee on the other side, so that people are incentivized to use the channel to route the other way around. And of course, it takes some coordination with your peer, because each is only responsible for their side of the channel, at least for nodes that don't have inbound fees. But LND, for example, have inbound fees, so they can even adjust the other side of the channel. But since your partner has also an incentive that the channel keeps being used for routing, it shouldn't be a problem. It's more practical than network-wide coordination, like in this research. And then I think it's becoming clearer and clearer that when this adjustment, this rebalancing through fees isn't enough, then you probably have to go on chain to either move liquidity from one channel to another, or to open or close channels. But still, it was interesting to see what's possible. At least theoretically, it gives us an upper bound on what is possible to do through secular rebalancing. Great. If there are any questions, feel free once again. Now to Boltz Pro, which was announced. So it was the end of the beta, and the official release of Boltz Pro was announced almost 2 weeks ago now. And so I'd like to first do a quick reminder of what Boltz is and how swaps work, and then we'll see what it means in practice. So Boltz basically is boltz.exchange, I can show you what Boltz looks like. There you go. So basically, Boltz is a way to swap funds, swap liquidity from Lightning, but now also Liquid, Bitcoin, and Roadstock into another layer of Bitcoin. And so, for example, if you have funds on Lightning, inside the Lightning channel, you can swap them against Bitcoin on-chain, and vice versa. You can have Bitcoin and swap it for Lightning, etc., etc. And you'll see, for example, that if I want to, let me take the same example, yes, on-chain to Lightning. If I want to receive funds in the Lightning channel, for example, if I say that I'm going to send 100,000 sats on Bitcoin, I'm going to receive a little bit less, because there is a network fee, the on-chain fee, and there is the Boltz fee, which is 0.1%. And so how does it work? Basically, the way it works is that the user will create an invoice. So in the case I depicted, of course, it will depend on which side which side of the swap you're going to take. But let's take the example of a user who wants to send on-chain funds and receive funds on Lightning. The user will create an invoice, which is what we expect, since they want to receive on Lightning, for the amount they want to receive, so which is the amount that Boltz gives you in the user interface. And then it gives the invoice to Boltz. And so in the invoice, there is the hash of a preimage, so random number that the user created, as in all Lightning invoices. With the invoice, Boltz can then create an address, a Bitcoin on-chain address, that logs the funds to Boltz public key, as well as revealing the hash, as well as revealing, the preimage of the hash that is in the invoice. That's what you can see here. Here you can also see that there is a lock time, and after this lock time, the user can claim the funds back. So it's a refund mechanism. In case for the swap doesn't happen or doesn't happen in time, the user can get a refund and get back the fund on chain. But yeah, let's not go into this this part of the swap. Let's say the swap is successful, and so Bolt creates this address that logs the funds to both the public key and the hash of the invoice. It means that even when the user sends the funds, Bolt cannot spend them, cannot claim the funds, cannot take the funds on chain because they don't know yet the pre-image of the invoice. So the user can safely deposit the funds on the on-chain address. So they do an on-chain transaction, sending the fund to the address that Bolt just gave them. And after one confirmation, Bolt can now pay the invoice. And so when they pay the invoice, the user reveals the pre-image to claim the funds on Lightning. And now Bolt knows the pre-image, and so they can spend the funds that are on the on-chain address and send them to one of their regular addresses without time lock or other exotic scripts. So they can send them to a normal address. So that's basically the typical swap on-chain to Lightning. And so of course you can swap the other way around, and we saw that you can swap to Liquid as well, to and from Liquid. And so we saw as well that in practice, Bolt defines fees. So there are an exchange rate and also fees. So not really an exchange rate, but fees, yeah. And so that's what we saw here. It means that the user needs to send more to the on-chain address than they are going to receive on Lightning. We saw that if the user sends 102,000 sats on-chain, they will only receive 100,000 sats because there are on-chain fees and there is the 0.1% fee from Bolt. But now, when everyone wants to swap in one direction, what can happen is that Bolt can find themselves in a situation where they don't have enough liquidity to fulfill all the swaps, or they could at some point run out of liquidity, and they don't want that because they want to be able to perform swaps for their customers. And so when that happens, they can incentivize other users to perform the opposite swap. So AJ, for example, if most users do Lightning to on-chain, then they can incentivize other users to do on-chain to Lightning by paying them a fee instead of charging a fee. So if we go back to the Bolt website, here the fee would be negative. For example, if you want to incentivize user, it would be minus 0.05%, for example, I don't know. And so this way, Bolts can basically use the liquidity of others in order to continue operations. And as long as it doesn't cost more to Bolts than it would cost them to source liquidity elsewhere, then it's a win-win situation, and everybody wins for that. So I think it's very interesting. It creates yet another market for people who have excess liquidity, for example, to try to make a self-custodial risk-free yield on Bitcoin, on their Bitcoin. And so they published an announcement. So they remind people that so it's not designed for when you are in a hurry and you really need funds, because Bolt's Pro Lightning payments are optimized for cost and not for speed. And so you also need to wait for an opportunity to arise. But it's perfect for Lightning node operators looking to decrease excess inbound liquidity and unsat, professional collaborating with external node operators to manage liquidity and unsat, users who want to top up their Lightning wallet, like Phoenix, but not in a time-critical way. So you know that you would like to add funds to your Phoenix wallet, but you're not in the queue, in line at the store, needing funds now. And so you have automation as well, so that you don't have to be behind your screen all the time to snipe negative fees and to find what we could to find opportunities. You can automate all this stuff. Yeah, so great, great little release. And so now there's more. So we can cover, for example, LNURL flip. I found it quite funny. Let me grab my other window. So here you have the announcement from Bolt. Yeah, Bolt Pro once again. And yeah, so it's a nice new tool from Lightning Eric Channels, which basically sits on top of LNURL pay and LNURL withdraw. So as a reminder, LNURL pay and withdraw, basically it's allow you to create links, strings, QR codes, that abstract away the use of invoices from users. For example, LNURL pay is quite similar to Lightning addresses, and actually Lightning addresses came after and reuse part of the LNURL pay flow. And the idea is that you scan the QR code, and then your wallet will automatically so it will ask you for it will automatically fetch details from a server. And for example, the server can say that the maximum amount that you can deposit is 10,000 sats, I don't know. And then the wallet will display that information to you and ask you how many sats you want to send. And you say that you want to send 5,000 sats. And then the wallet will automatically, behind the scenes, send an API call to the service you're trying to deposit to. And ask for an invoice for 5,000 sats, and the service will respond with the invoice, and then the wallet will pay the invoice automatically, or they can ask you for confirmation also, but the wallet will automatically process all the invoice aspects. And for LNURL withdraw, it's quite the same, but in the other way around. Basically, you scan the QR code like in LNURL pay, and then what your wallet does, it asks the service things like how much is the maximum that you can withdraw. The service responds with this information, and then your wallet asks you how much you want to withdraw. You input the amount in your wallet, and then the wallet creates an invoice and sends the invoice to the service, and the service pays the invoice, and you receive the funds on your wallet. So basically, the core idea behind LNURL pay and LNURL withdraw is that Lightning invoices are not very user-friendly, and we want to abstract them away from users as much as possible. Basically, it's the idea. So it's a huge win in terms of user experience. And so the LNURL flip project, which is an LNbits extension, basically the idea is to have LNURL pay and LNURL withdraw, but in one QR code. And so you can use this, for example, for faucets. So Faucet is a little service where people can claim funds for free. There was one very famous Bitcoin faucet where you could, I think, you could claim 5 Bitcoin in the beginning. Yeah, you just had to input your Bitcoin address, fill a captcha, and then you would receive 5 Bitcoins because it was not worth a lot at the time. And so you could use LNURL flip for example, for faucets. And so the idea in LNURL flip is that depending on the amount that is available in the LNbits account, it will, so when your wallet scans the LNURL, they get basically an API endpoint that they can call. And when they call the endpoint, the response of the endpoint on the endpoint of this LNURL server will depend on the available balance. And so if there is balance available, they will respond with an LNURL withdraw response, allowing the wallet to withdraw funds. And if there is no balance available, they will respond with an LNURL pay response, allowing the wallet to deposit funds. So I guess, depending on how wallets are implemented, it may or may work more and less, because, for example, if there are wallets where you first need to click send and or receive, and then they will interpret what the data from the LN URL server, depending on the action that the user intended by pressing send or receive. Maybe this won't work, but in wallets where you just scan a QR code and then the wallet figures out from the LN URL server response what is the action that the user wants to take, then this should work perfectly fine. So you can give it a try if you want. And so there is the code here, and as you can see here, depending on is it here? Here? Yeah, it's here. Depending on the balance, you can decide whether it's a pay link that you're going to send back to the wallet, or if it's a withdraw details. Yeah, great. And maybe another thing I wanted to share is liquidity stir. I think we very briefly touched on this tool a few weeks ago when we also talked about on-boss rails. And so basically the idea is to have a liquidity aggregator built on Noster. And so I find it quite interesting to have this coordinated over Noster. It's really in the idea of having things done peer-to-peer without established middlemen and things like that. And so the interface, I think, resembles a bit the Magma marketplace, but yeah, you can't really, there aren't really 10 different ways of building something like that. And you can basically select an LSP. So a node that will open a channel to you with inbound liquidity. You can adjust how the inbound you want to receive, things like that. So yeah, I would just wanted to give a shout out to this service. Right now, I don't know if there are other ways. So because basically the idea, it becomes really interesting if there are multiple clients, multiple solutions that allow liquidity providers to connect to this Noster coordinated marketplace. Right now, I think it's only this tool, which is the tool we spoke about, Pub LSP, which is a CLI tool. So you run this in the terminal that allows you to advertise this liquidity. And then, because it uses a standardized event kind on Noster, it will be picked up by this user interface, and you will be shown to users as long as you publish this to the right relays. So, for example, we could imagine there are many, maybe there could be multiple built-in board like this one with different relays, and if you want to maximize the chances of your liquidity, of your liquidity, of your proposition to be seen by others, you would publish the announcement, the event to multiple relays at the same time. So it looks a bit like liquidity ads, which is another concept a bit similar, where in liquidity ads it's more Lightning native, and the idea is to advertise on the gossip layer of Lightning itself that you have liquidity available and that you are open to open a channel with someone on this and that terms. So you can specify the fees you want to take and things like that. And so here it's a bit like liquidity ads, but using Noster as a coordination layer instead of using Lightning's gossip layer. And I think ultimately it's really cool to have all these kind of coordination layers. You have liquidity ads, you have this Noster liquidity marketplace, you have Emboss's Magma marketplace. And so maybe a fun thing to develop would be maybe an aggregator on top of all that could listen to liquidity ads, that could fetch data from the Magma marketplace with APIs, that could also run a relay and get offers from Noster and aggregate all these sources into one final website. So it could be something that we could work on in the lab. So feel free to tell me if it's interesting, if you think that it would be something you want to work on, because I think it could be interesting. And yeah, if you're interested in that, I would definitely love to help. If there are a few of you in the lab wanting to work on that, we could coordinate and try to get something working quickly. Great. I think that's it for today. I will share again the. I think I lost Canva. No, it's here. Perfect. I will share again the the QR to the Telegram group. Feel free to ask if you have any questions. Once again, thanks a lot for joining us today. As I mentioned, yeah, maybe it's a bit shorter than usual, but because I didn't catch a lot of things in the news over the last 2 weeks. Feel free to, if I missed something, feel free to tell me as well. Maybe there are things that I overlooked. Feel free to mention them in the Telegram group if you want. Thanks a lot once again, and yeah, see you guys in the Telegram chat and in the next live session. Thank you. Bye bye.